Good morning and welcome to math class. Oh, that's right. Some of you still might be sleeping in and doing math later in the afternoon. So good day to all of you as well. Hopefully everyone is safe and healthy. We miss seeing everyone's faces here at school, but remember that your teachers are always here for you to help you with not only homework, but any other concerns you have. We are a phone call or an email away. All right, so let's go ahead and get started on our lesson for today. If you notice, we're going to move on to lesson 10. We are still working with rational numbers and putting them in order from least to greatest, but today we're going to do something new. We're going to add something called an inequality. Most of you know what that is. You probably did it when you were in third grade math. It's the alligator mouth. The alligator mouth that helps us know which number is bigger or smaller. So go ahead and make the inequalities. We'll make this one. This one is called less than. And then let's make a copy, obviously, of the other one, which is called greater than. Just to give ourselves a little note to help us remember which is which. All right, so let's go ahead on to our opening exercise. It says the amount of money I have in my pocket is less than $5, but greater than 4. So I'm going to do a quick number line. If I had 0 here, I am looking at the fact that it is less than 5, but greater than 4, so I'm looking at an amount of money right here. Mr. Keith, what did you say? Did you say that you have $4.75? Well, let's go ahead and put one possible value for the amount of money in my pocket is $4.75. That is an answer between 4 and 5. Well, now we're going to take that and we're going to write it in an inequality statement. But you notice it says comparing the possible value of the money in my pocket to $4. Well, we have the $4.75 and the 4. They want me to compare it to 4. So I have 4. My other rational number is $4.75. Now I have to add my alligator mouth. Remember, the alligator mouth eats the larger number. $4.75 would be larger than 4. So I would put this inequality. 4 is less than $4.75. Okay, this time it says to write an inequality statement comparing the possible value of the money in my pocket to $5. Well, the money in my pocket was $4.75, and the number they're wanting me to compare it to is $5. Now I have to add my inequality. $4.75 is less than $5. Okay, so I heard some of you saying, well, couldn't we write it the other direction? And you are correct. We could write it the other direction. We could have put the 5 first and the $4.75 second, but this time our inequality would obviously face the other direction. We would have to say 5 is greater than $4.75. Okay, so we're looking at inequalities today and putting our rational numbers in order. Let's go down to exercises 1 through 4. It says graph your answer from the opening exercise A on the number line. Also, graph the points associated with 4 and 5 on the number line. So the first thing we're going to have to do is we need to look at our number line, and we kind of need to decide how we want to number it, what the pattern is we want to do. Well, since I'm looking at putting something between 4 and 5, I'm going to put 4 to the far left because it's smaller, 5 over here, and I'm going to count by tenths, which means I have it like this. 4 and 1/10, 2 tenths, 3 tenths, and so forth. Go ahead and pause your video so that you can number your number line, please. Okay, so you can see I have my number line numbered already. I have to graph the point 475 that we have up here. 475 is going to come here between 4.7 and 4.8. So I'm going to put a dot right here. And then it says also graph the points associated with 4 and 5. So here's 4 and here's 5. Explain in words how the location of the 3 numbers on the number line supports the inequality statements you wrote in the opening exercise in parts B and C. So I have to look at where they're located, and I have to write a statement. Now remember, a statement is a sentence, a capital letter, and a period. So if I'm going to make a statement about these numbers on the number line, I could say something like the numbers are in order from least to greatest, right? From left to right. And I could say that so 4 is obviously less than 4.75, and 4.75 is obviously less than 5. Go ahead and pause your video so that you can write your statement. Otherwise, you can follow along and take a pause after I have my statement written. Okay, so as you can see, I wrote here that the numbers are in order from least to greatest, and I kind of made a list of them. I have 4, then I had 4.75, and then I had 5. Okay, so I kind of explained the order in least to greatest order. If you need to pause so you can write this, please do so. Problem number 4 says, write one inequality statement that shows the relationship among all 3 numbers. Well, the 3 numbers, I'm going to go ahead and write them here, and I'm going to kind of leave a space in between them so that I can add my inequality. Remember, inequality are those alligator mouths. So I'm going to first look at these two. I have 4 and $4.75. Well, $4 is less than $4.75, so I'm going to put the less than inequality. Now I'm going to look at this side. $4.75 compared to $5. Well, $4.75 is less than $5. So I have a large inequality statement here. 4 is less than $4.75, which is less than 5. This is called an inequality statement. Okay? All right, so we're going to move over to the back side, which is example number 1. We're going to continue writing some more inequality statements. Let's read the directions. It says, write one inequality statement to show the relationship between the following shoe sizes: 10.5, 8, and 9. So those are my 3 numbers that I have, or rational numbers that I have. So the directions say that I need to write those numbers in order from least to greatest. Well, 10.5, 8, and 9. Looks like 8 is the smallest. I'm going to leave a space, and then here comes 9. After 9 is 10.5. Okay? Inequality statement means I'm going to write it with the alligator mouth, the inequality. 8 is less than 9, and 9 is less than 10.5. Okay, so I have gone in order from least to greatest. Now I have to change it around from greatest to least. Well, the greatest number, I'm just going to turn it around, was 10.5. Then came 9. Then came 8. This time my inequality statement is going to go the other direction. 10.5 is larger than 9. 9 is larger than 8. So I have an inequality statement, but this time I'm going from greatest to least. Okay, let's move down to example number 2. Example number 2 says, Mary is comparing the rainfall totals for May, June, and July. The data is reflected in the table below. Fill in the blanks below to create inequality statements that compare the changes in total rainfall for each month, the rightmost column of the table. All right, let's see. We have the months May, June, and July. This year's total rainfall, last year's total rainfall, and the change in total rainfall from last year to this year. So this is the column they're wanting me to look at. And the directions ask me to do to fill in the blanks below to create inequality statements. All right, so let's look at the first thing. Write one inequality to order the changes in total rainfall. So I need to look at this, and it says from least to greatest. All right, so here's my 3 rational numbers. Obviously, negative numbers are smaller than positive. So I'm going to put negative 1.4 first. Small line, so we might have to write tiny. So let's see, what would be the next smallest number? 3/10 or 5/10? Well, if I'm having a hard time, I might think of it in terms of money. 30 cents and 50 cents. 30 cents is much smaller. So I'm going to leave a space and put 3/10. And that means 5/10 is larger. My inequality statement would look like this. Negative 1.4 is less than 3/10. And 3/10 is less than 5/10. Now we're going to take the exact same rational numbers, but this time we're going to change them in order from greatest to least. Well, we found out that 5/10 is the greatest number. 3/10 was next. And obviously our negative number is the smallest. We're going to add our inequality. 5/10 is greater than 3/10, and 3/10 is greater than negative 1.4. Okay, so we're still doing the same kind of concept that we've done earlier, but this time we're adding inequality statements. Okay, let's go on to the next problem. In this case, does the greatest number indicate the greatest change in rainfall? Explain. So what the question is asking is asking which one is the greatest change in rainfall. If I notice, these were the three rational numbers I had. So I have rainfall. In the month of May, it went down 1 4/10. In the month of June, it went up by 3/10. And in the month of July, it went up 5/10. But if I look at which one of these would be the biggest change, the biggest change would be in the month of May. It changed by 1 4/10. So the month of May would be my greatest change. Okay, so go ahead and pause your video for a second, and you will be able to write this down. All right, so here's my answer. I said, no, the greatest change is for the month of May, since the total rainfall changed by 1 4/10. So once again, we look at the numbers over here. Okay, the rainfall here went down 1 4/10. That's a bigger change than to go up by 3/10 and 5/10. Okay, but our greatest number, recall, was here at 5/10. Okay, a little confusing. As you can see, Mrs. Hawk is a prime example of why we should be using pencil for math instead of pen. I had to correct my capitalization on the month of May. Okay, so when you are ready and done writing this down, you may flip over to the next page. Okay, so we're just going to do a couple more problems here. Let's look at problem number 5. Number 5 says Mark's favorite football team lost yards on 2 back-to-back plays. They lost 3 yards on the first play. They lost 1 yard on the second play. Write an inequality statement using integers to compare the forward progress made on each play. Well, loss of 3 yards. A loss would give me a negative number. And a loss of 1 yard would also be a negative number. So now we have to add our inequality in between the two of them. Go ahead and put your inequality. Tell me which way the alligator mouth would be going. Is -3 less than or greater than -1? Ella, you are correct. -3 is less than -1. Remember, my number line's here. -1 would be here. And -3 is further away from 0. So here is the correct answer. Okay, let's move on to number 6. Number 6 says Sierra had to pay the school for 2 textbooks that she lost. One textbook cost $55. Cost $55. And the other cost $75. Her mother wrote 2 separate checks for each expense. Write 2 integers that represent the change to her mother's checking account balance. So that's the first thing we have to do. And the second thing we have to do is then write an inequality statement that shows the relationship between these two. So here's the second thing we have to do. All right, so first thing is write the 2 integers. Well, a cost would be a negative. I'm paying $55. The second integer, a cost of 75, would be a negative 75. All right, so we did the first part. We wrote the 2 integers. Now we have to write an inequality statement. Well, I'm going to go ahead and just keep them in the order that I have here. I have -55 and -75. Now I want you to go ahead and take a guess and put the inequality in between those 2 rational numbers to see which one is greater than or less than. What would be worse, to pay 55 or 75? Let's see. Morgan, did you say that -55 is greater? You are correct. -55 is greater than -75. Now remember, you could always write them the other direction. We could have put the -75 first and the -55 second. However, we would have had to change the direction of our inequality because -75 is less than -55. Okay, so what I would like for you to do is I would like for you to go ahead and just solve problem number 7 for me for tomorrow. Let me read it for you real quick. It says, Jason ordered the numbers -70, -18, and -18 and 5/10 from least to greatest by writing this statement. This is what he put. I want you to tell me if he did this correctly. Is this statement true? Okay, if you think it's true, tell me it's true. If you think it's false, tell me it's false. And then tell me why you think it's false. All right, I will see you all